Okay, let's get this show on the road. We're
Sure.
1 minute past 10, so there's a chance for others to join. I'll introduce Paul Kearns, who's going to make some opening remarks, and then I'll introduce our guest speakers to today, and then just run through some of the housekeeping and procedures. Just to let everybody know, this is going to be recorded, and it's in accordance with the Price Forbes privacy policy, which is available on the priceforbes.com privacy-policy link, which you can see to the bottom right of the current screen, and also available through our website. So I'll hand over to Paul, our Deputy CEO at Price Forbes, for some opening remarks.
Thanks very much. Well, good morning, everyone, and welcome to the first Price Forbes Hydrogen and Clean Energy webinar. I mean, for me, hydrogen's always been spoken of as the fuel of the future, always promising sort of to deliver huge benefits, but in about 5 years' time. But that conversation, I think, is changing. And with global emissions of CO2 from industry and fossil fuels in 2019 estimated at a little under 37 gigatons, obviously significant reductions in emissions will be required if we're to achieve anything like the goal set out in the Paris Agreement. Green hydrogen is going to play a huge role in the reduction of global emissions as countries battle to meet these targets. And whilst the technology isn't new, the green hydrogen production costs have now fallen by some 40% since 15, and according to Forbes, they're expected to fall by a further 40% by 2025. So investment in green hydrogen production also set to exceed several billions a year by 2023. And as the cost of both renewable power and electrolyzer technology fall, many governments are introducing both supportive financial policies and others mandating these targets by law. So one thing is certain is that hydrogen is no longer a niche fringe fuel. I think the element will play a critical role in the decarbonisation of the sectors where electrification isn't possible, and with insurers, needing to develop the products to support this growth along the way. And I think the green energy revolution's already begun, which is why the Price Forbes teams have set up a cross-division hydrogen team with members from our energy, power, construction, renewables, marine, and liability teams. So it's fantastic, therefore, that we can see so many of the representatives from across the entire market here showing your interest in the development of the hydrogen technology. And we hope you find the webinar beneficial. And we look forward to working with you all on the hydrogen projects in the future. I mean, the importance of these forums, I think, and initiatives, probably never better illustrated. Temperatures in Canada, Canadian heat wave reaching 50, with many of the scientific bodies attributing certainly some of the contribution to that from climate change. So I know that time is pressing and we have a limited time, so without further interruption, certainly from me, I'll pass you over to my good colleague, mediator Andrew. He's going to introduce our guest panel, and I look forward to better understanding the issues and the opportunities that are in front of us today. So over to you, Andrew. Many thanks.
Thank you, Paul, and thank you everybody for joining us this morning, 1st of July. Actually, to the day, 36 years since I joined Cedric Offshore Resources in the oil and gas team. And the symbolism there is that I joined at a time when the North Sea was expanding rapidly. There was a huge growth of knowledge being developed in the engineering side, and ultimately also in the insurance sector, developing wordings, understandings, capacity to address the new risks offshore for deep water oil and gas. And the symbolism is that I feel personally that we're at the cusp of something similar, where we can develop the skill base in London to be a leading skill on a global basis for hydrogen. I'm delighted to introduce two guests today. Chris Jackson. Some of you may know Chris. He used to be at JLT until 2015, so he may be familiar to some. He is currently the chairman of the UK Hydrogen and Fuel Cell Association. He's also the CEO and founder of a company called Proteum, providing green hydrogen services to many companies. He's also the consultant to many organizations in the hydrogen fuel cell space through those roles. He also co-hosts a podcast called Everything About Hydrogen. So those who are into the modern media podcasts, you can keep in touch with the hydrogen development discussion. And Chris will speak first, and I'll hand over to him shortly. Our second guest speaker is Andy Cummings. 30 years experience in the gas engineering sector and with the NV at Spade Adam, the testing and research development area in the north of the country. And for those who haven't been there, I certainly recommend attending. It's a very eye-opening experience to potential gas explosions and other risks. He's recently been the president of the Institute of Gas Engineers and Managers in the UK, which provided a massive insight to the energy transition requirements in the gas area. He's currently the project manager for H21 project at Spade Adam DNV, looking at the network transportation system that we currently have and the safety and safety aspects of introducing hydrogen to that system. So I'll introduce Andrew as a second speaker later. So Chris, I'm going to hand over to you. Before I do so, there will be questions afterwards. We've had some questions sent to us by underwriters, and we'll have a Q&A session at the end of the two presentations.
Well, Andrew, thank you very much for the introduction, kind introduction, and good morning, everybody. It's a pleasure to be speaking here at this event. I'm going to try and see if we get this to work and load up the slides. Here we go. Right, hopefully everyone can see my screen. Right, and if I remember this last time, you're doing this. Okay, I think everyone can see me. So good morning, everybody. My name is Christopher Jackson. As Andrew mentioned, I'm the chair of the UK's Hydrogen and Fuel Cell Trade Association, and also the CEO of Protium, a UK green hydrogen energy company. Just a quick background for those of you who are not familiar with the UK Hydrogen and Fuel Cell Association. We are the UK's largest pan hydrogen and fuel cell trade group, representing about 70 companies in the space, including almost all of the large UK electrolyzer manufacturers. So that's ITM Power, CPH2, Ceres, who do solid oxide electrolyzers, and TP Group, that also do the electrolyzers for the British and French nuclear fleets. We also include some of the largest producers of hydrogen, which includes Air Products and BOC, as well as partners like BP and EPCs like Petrofac. As a group, we sit and represent various issues around hydrogen to the government, both in the UK side, but also internationally. We're part of the government's Hydrogen Advisory Group, and recently also part of the UK Energy Supply Chain Task Force that the EIC is chairing with Cabinet Minister Stewart and Cabinet Minister Trevelyan from BEIS and DIT respectively. So we're playing quite a significant role at the moment in trying to ensure that the opportunities of this next wave of the zero emission transition is essentially one where the UK can take the most opportunities to really lead in and develop a strong manufacturing and skills base. And obviously, it can stay a key part of that process and continue to be a leading market, as well as more broadly the London market. And insurance is something that we're obviously keen to support as well. So getting right into it, a little bit of background. I think people probably by this stage will have been reading a number of articles around hydrogen and probably asking themselves, why are we talking about hydrogen now? What is the relevance to the particular discussion today? So maybe as a quick starting point, so today we produce around 110 million tons of hydrogen annually, 70 million tons of which is commercial. It's about $135 billion market annually, with around 50% of it going to the production of ammonia and the balance going to processes such as the refining sector, hydrogenation of fats, direct reduction of iron, and various other applications. What we are talking about more broadly in the press, and I think more broadly in industry, is looking at the opportunity to use hydrogen as a fuel for the energy sector transition. And really, there are several drivers behind that. The first is kind of a bit more of a macro picture story, which is that when you look at the global energy consumption pattern, around 20% of total final energy in the world is consumed as power, and the other 80% is in transport and in heat. And when you look at the story of decarbonisation over the last 25 years in those three blocks, you'll see that we've made reasonable progress in the power sector in decarbonisation and almost no progress in heat and almost no progress in transport. And a large part of that is because while electricity is a very valuable source, a very valuable form of energy that I think we all use today, it's not particularly convenient, it's not particularly flexible, and it doesn't actually provide necessarily all of the things that we want energy systems to provide us from. And that's why we continue to use fuels like oil, diesel, coal, natural gas. And so the sort of holy grail of the energy transition is, how do we introduce that level of flexibility? How do we introduce that level of practicality around zero emission technologies, and how can we convert the increasingly cheap and abundant sources of renewable electricity we have, solar, wind, hydro, potentially wave and tidal, and convert that from electricity that has to be consumed at the point of generation into a fuel that we can actually store and use for a much broader array of applications. So that's obviously the green hydrogen piece. The blue hydrogen conversation, for those who are less familiar, that is reforming hydrogen from an existing fossil. So that could be natural gas, it can be coal, and then capturing the CO2 and storing it. That piece is largely, again, trying to think about how can we, in the most cost-efficient way possible, reduce the amount of CO2 that we're emitting from processes where there may not be an availability or an abundance of renewables today. And so it's seen as an intermediary step towards that decarbonization story with green hydrogen. So the slide you have in front of you is one from the Hydrogen Council, which is a global trade body on hydrogen. And as we say, the starting point for why there's been a lot of discussion around hydrogen is this idea that as we add more solar, more wind, and more intermittent sources of renewable power to our global grids, we will need to find ways to integrate that. I think many people might be familiar with the concept today that we have of curtailed power in a number of markets, or the duck curve, as it's called in Germany or in California, where you have huge peaks of power that far exceed what is needed on the grid. And then obviously as the sun goes down, you have these massive troughs, and that's having to be picked up by gas, or in some cases even by diesel. So one element of hydrogen is trying to figure out on the green hydrogen side how we can integrate that and reduce some of those risks. The other is, as I mentioned, point two is, how do we take that electricity and how do we distribute that to other sectors? How do we convert electricity into a form of fuel that we can use for heavy goods transport, for shipping, for aviation, or indeed for our heating and industrial processes? And how can we use that to give us the same system level resiliency we want? Many people will be familiar that in the UK, we have a relatively significant amount of stored electricity in the form of pumped hydro. That represents about 0.21 terawatt hours of stored electricity. But we sometimes forget how much energy we store as fuels. To give you a comparison, we store 5 terawatt hours of fuel in our cars on the roads today. So just in the petrol tanks of trucks and buses and cars that we have in the UK today, we're already storing a factor of nearly 40 times more energy than we store in our current electricity system. So finding ways of converting more electricity into forms of energy we can store is critical. And obviously with that, then it's about decarbonizing those hard to abate sectors, that final 80% that I talked about earlier. So that includes forms of transport where the weight of batteries is a barrier, or where the use case of transport requires fast refueling times and long distances where batteries have less of a competitive advantage. It includes decarbonizing industry, where there are potential areas of very high heat requirement, areas that might be remote, and so there's not an access to large amounts of grid, and therefore you cannot simply rely on an all-electric solution. It may, in a number of cases for homes, be actually a more cost-effective solution, especially in those remote homes. For example, in the UK, 5 million homes aren't even on the gas grid. So when we talk about decarbonization, it's not always the case that one size will fit all. There will probably be a need for multiple solutions. And so green hydrogen and blue is potentially one of those solutions, alongside heat pumps that will be part of that decarbonization. And finally, the idea then of using hydrogen to actually create products. So where you can capture carbon from an industrial process and combine it with hydrogen to create products like green methanol or green ammonia. And these can then be used for the shipping sector or for other sectors where, again, we need to decarbonize. So in the last 3 years, we've seen a huge amount of additional interest in and around hydrogen. Hydrogen Council's tracked about 228 projects globally. At the moment, there's line of sight on about $300 billion of projects that have been announced publicly, of which they think about about 80 billion is significantly advanced, and then another 220 is in its earlier stages of development. They've been largely European concentrated till now. However, there's a huge amount of movement now in North America, with the latest announcement of a moonshot program to try and get the cost of hydrogen down to extremely low levels by 2030. There's also a huge amount of interest in Asia, specifically in places like Japan and South Korea, where there's a lot of discussions around actually saying, can we replace the coal-fired power stations we have today with ammonia, where that ammonia is created from renewable sources. And so a lot of very, very cheap renewable locations, including Australia, Oman, Chile, and others, are looking at, can we use our abundant solar and wind resources to create cheap green ammonia and then use that inside a lot of these existing power plants so that we don't have to replace existing assets, we can repurpose them and decarbonize them. A little bit of terminology for those who aren't familiar. Hydrogen has, unfortunately, a lot of colors and it confuses a lot of people. So just trying to make this fairly simple. Broadly speaking, when we talk about green hydrogen, we're talking about hydrogen that either comes from a process called electrolysis. So if you remember your school chemistry classes, that's using an electrical current to split water into hydrogen and oxygen, or it can be the reformation of a bioenergy source. So that can be biogas or biomass, where you're essentially saying that the carbon associated with that is net zero because it's a form of carbon that already exists in the environment today. You're not adding to it. And as a result, you're then splitting hydrogen from that carbon-based fuel, and that is considered green. Gray hydrogen is where you're extracting hydrogen from natural gas, and you're just releasing the CO2, which accounts for the vast majority of hydrogen production today in Europe and in North America. Brown hydrogen is where you're taking it from coal, and again, it's a similar process, reforming, gasifying that coal and then extracting the hydrogen from it. And blue is essentially where you're able to capture the CO2 that is coming from those fossils that have been converted into hydrogen and then store that CO2. And as sort of I think many people will be sort of aware, and we've touched on before, there has been a huge step up. So in June 2019, there are about 2.9 gigawatts of hydrogen projects announced globally. And by October 2020, there are about 36 gigawatts of projects announced globally. There are some slightly interesting elements around this slide, but I'm going to move on in the interest of time and we can kind of come back to it. But all of which is just to say, this is a very fast moving space. There's clearly a lot of potential excitement around it. And so what I kind of wanted to do next was actually show you some images of what we're really talking about. Because I think quite often when we read articles about hydrogen or read reports or we hear presentations, it's quite abstract. So I wanted to make it a little bit more tangible. So starting with this slide, let me just show you a few pieces here. So the top right is an example of how we use hydrogen today. So it's a 25 megawatt alkaline electrolyzer site in Malaysia. It's used to create hydrogen for the polysilicon manufacturing industry. Sites like this are relatively common. So when people talk about hydrogen technologies being new or the absence of large-scale hydrogen being deployed, there are many, and a number of these will already be insured inside the markets today. This particular one is done by a company called Nel, formerly Norsk Hydro, that's listed in the Norwegian Stock Exchange. The image in the middle is a Siemens electrolyzer. The site is a 6 megawatt electrolyzer site built in Energy Park, Mainz. It was built in 2015, connects into an onshore wind farm of around 20 megawatts. Again, has been operating now for over 5 years. In the far left is a refueling solution for forklifts or material handling. Unusually, most people wouldn't have thought it, but forklifts are actually a very popular application for hydrogen. So around 30,000 forklifts globally run on hydrogen. That's around 1/3 of all Walmart and 1/3 of all Amazon's depots in North America that run on it. And actually, the business case is very commercial. Some of the individuals involved in that argue that they will make a return on capital within 12 months. So really interesting business case, very fast refueling times, very limited site footprint. Image bottom left is hydrogen storage at Valcladec, which is a nickel refining site in South Wales. It's been there for 120 years, right next to a residential area. Again, just showing that these assets have been around for a long time, but people might not be familiar with them. Bottom image is cryogenic hydrogen that again is produced in mostly Europe and North America rather than in the UK, which is used for the forklifts, which we've referred to in the top left. And then just kind of giving you an example of things that you probably aren't aware of when it comes to versatility. The image on the bottom right is a hydrogen barbecue, because there's quite a few different things you can use hydrogen for. A few other quick ones here. So image on the left is the Woking Leisure Centre, which has had a fuel cell operating in it since 2000. It was actually funded by the US Department of Energy. So for anyone who's around there, that's an example of technology probably under your nose. The other one is that there is actually a fuel cell system in the walkie-talkie building in London. So again, people might not be aware of that, but there is a system that's been running there for over 5 years too. There are fuel cell buses operating now, roughly over 3,000 globally. The image on the top right is one in Northern Ireland, but there are others that have just been announced in London, in Birmingham, a number coming into Liverpool and Brighton, and several hundred in Europe. And also hydrogen cars. That includes the Green Tomato taxi fleet in London, where there's 50 Toyota Mirai, but also things like street cleaners, which we're starting to see in Glasgow. And then increasingly trucks as well. So the top right was the first 20 Hyundai Exient 20-ton trucks that were delivered into Switzerland last year. Dual fuel, diesel and hydrogen trucks in the UK, like the DAF image on the top left. And for those of you who go past the Cobham M25 station, there is a hydrogen refueling station that's also there. So you can drive and see that whenever you want to. So what does a green hydrogen project actually look like visually? So I'm going to give you an example here. This is a 20 megawatt solar PV project with a 10 megawatt electrolyzer. It's in Fukushima in Japan. The hydrogen produced is then injected into the gas grid, and they blend it up to 5% with natural gas. And it's a way of increasing the amount of domestic renewable resource available, but converting it into a form that's most needed in the area, in this case, gas rather than pure electricity. So just a bit of a whistle stop, but hopefully gives you some ideas. And repeating something that I'm sure many people will have said before, this is an old technology. Electrolysis itself as a process over 100 years old. This is a 130 megawatt alkaline electrolyzer in 1949. Large-scale electrolysis was very common in the days prior to mass shipping of ammonia, because frankly, it was a local game to create hydrogen, and it was largely done behind large hydropower sites. So Egypt, for example, or Nepal, or places like Zimbabwe or China did have, and many still do have, large existing alkaline electrolyzers. In the UK, we also used to have a large portion of hydrogen in our gas grid. From those who remember the town gas grid systems, or families who might have had town gas, there was at one point 50% of all the gas within the UK system was town gas. So it was hydrogen within the town gas system. And that actually, by our calculations in 1970, meant we were consuming over 700,000 tons of hydrogen within the gas grid at the time. So, when we talk about blending into the gas grid, we talk about hydrogen in homes, we talk about changes of applications. A lot of these things have already been done before. And indeed, over a 10-year period, we moved from a town gas system to a 100% methane natural gas system and changed over 40 million gas appliances at the time. So when we talk about these things, they're not outside of the realm of the possible. And I think that's something we need to focus on a lot when we talk about the decarbonization challenges. It's not just what is the optimal for someone sitting in a room with an energy system model. It is also what is practical and what is deliverable. And actually, I think one of the pieces we see about hydrogen is that it's a technology and a solution that we've used before, that we're familiar with. There are robust procedures in place. And the question is, how do we make it commercially viable, and how do we expand its range of applications to find those appropriate solutions? Hydrogen will not be the answer to every single energy problem, but it will be a significant part of the solution for many. So some of what I've spoken about will have obvious implications for the insurance market, but maybe let's make them a little bit more specific. So clearly, given the size of the hydrogen market today and the fact that many underwriters are already covering ammonia production facilities, they're already covering refineries and other chemical sites, hydrogen is already being insured, or hydrogen risks are already being insured and placed within the London market. I think part of the challenge perhaps is that not within the conventional energy market, more likely within the property and other forms of specialty markets. And as we've mentioned, the key here is to think about the fact that hydrogen is moving now from being a process or a feedstock gas into being an energy source. And what does that mean from an insurance perspective? And what does that mean for the risks and end use profiles? And how can we then take the benefits of all that experience and lessons learned on how to insure, and the type of risks that are coming out of hydrogen production, storage, and distribution from those markets where it's already being covered today, and bring those learnings across into new markets that are less familiar with it. There are obviously areas as well where Lloyd's can lead on some of this, and other markets in London have led on new forms of technology. So from our side, I think that's where, from the industry, we'd like to see more engagement. I think the market could play a huge role in helping to unlock some of the financing opportunities around it by being able to show that these are risks that the markets have seen before and that they're comfortable with. Maybe just to recap some of those risks for those who perhaps are less familiar. There are a couple of the obvious ones. So fire and explosion. Hydrogen is a combustible gas. It has a it can be very quick to combust. It also doesn't have any smell, and it is also colorless. I'm sure my colleagues from DNVGL, who are speaking later, will go more into the technical pieces. Again, just to emphasize here, there are a large number of standards and practices around hydrogen, and there has indeed been quite a lot of work through a government program called Hy4Heat, which is being led by Arup and Bayes to look at how can you make hydrogen safer, what are the minimum standards for hydrogen applications, whether those are gas or whether those are other forms of end use. I think the other piece we then wanted to talk about here a little bit is around actually the specifics of business interruption, which is a little bit different in the energy market for green hydrogen, that maybe is a new risk that the market needs to consider. So here we have at the moment a situation where normally we'll treat renewable production separate from end use. As we start looking at these green hydrogen projects, and I showed you the image of Fukushima, a number of these projects, they will be integrated. So you will have renewables directly connecting into an asset, and it may be the case that those are one project entity, or it may be the case that they are several separate project entities. So there will be questions around how does business interruption work where one part of that system fails, and also when this starts to link into price support mechanisms as well. So there is a low carbon hydrogen price support mechanism in place in the UK and in the US California market. There's a new one coming into Canada, and there are several being proposed in Germany. All of those will be linked in many ways to the form of production. So they will be linked to the renewable resource that's available or the biogas resource that's available. So the current market at the moment doesn't seem to cover a lot of that, but a lot of the business cases around early green hydrogen projects will involve some degree of price support. So simply covering business interruption losses associated with the direct sale of hydrogen may not capture where the real margin sits, which can sometimes be in those price support mechanisms. And that's an area of the market that I think is interesting to consider. And the third piece that we've said is important to think about is the transportation side. So at the moment, relatively little hydrogen is actually moved from its source of production. There are hydrogen pipelines in place. So in North America, there's over 1,000 miles of hydrogen pipeline. There are about 400 miles of hydrogen pipeline in Europe. But in general, they are quite low. And where hydrogen is moved by road, it tends to be moved in relatively small quantities. So some estimates are that about 2 tons of hydrogen is moved in the UK by road every day, but that tends to be in fairly small quantities. As we start to see more distributed, decentralized production of hydrogen, where potentially that means more tankering of hydrogen on the roads, questions will come in around that and how that's ensured. And also, that will then determine, I think, some of the business models. How comfortable are the market and how comfortable are regulators with large volumes of hydrogen and potentially other products like green ammonia being transported by road as well. So maybe just explaining what some of these projects actually look like. So when we talk about a green hydrogen project, the main 2 ingredients, if you like, are the source of electricity and source of water. There are a number of different ways in which you can source that electricity and a number of different business models being pursued in the market to look at this. Some is additional renewables, so building new solar, new wind, new hydro. And part of that, as I say, is tied to government policy and tied to what some investors and some end users want to see, which is additionality, evidence that you're not simply repurposing electricity from the grid, you're actually adding new renewable electricity to the grid. Some projects are looking at connecting to existing renewables, so those that may already have contracted off-takers, they may already be under a feed-in tariff regime or some other form of price support, and some may just be a more generic grid connection where there is some form of power purchase agreement or deal signed with utility. When we're then looking at the electrolysis process, an electrolyzer itself, it's an electrochemical reaction. So in that sense, there's not a lot of moving parts, but there is an importance of making sure the water source is correct. So the most valuable part of an electrolysis system is the membrane. The wrong source of water can contaminate the membrane and can then lead to a loss on that asset. So that's something that's very important to consider, as is actually then the ultimate treatment of oxygen from that production process. So hydrogen obviously is the commodity that most people want, but there is a significant volume of oxygen also created on these larger projects. And in smaller electrolysis projects, oxygen can be vented, but in larger projects, that's unlikely to be deemed safe or appropriate. And so having the right measures in place to ensure that that oxygen is either being stored or is being released in a safe manner is important. And then obviously how you distribute that hydrogen afterwards. Is that going through a gas grid connection? Is that being moved by vehicle? Different projects have different configurations. I'm conscious DNVGO will talk more about this later, but it's worth emphasizing that in some countries there is already hydrogen safe or hydrogen ready pipeline infrastructure. So in the UK, there's a program called the Iron Mains Replacement Program that is looking at the transfer of the pipe from steel to polyethylene. It wasn't originally done for the purpose of hydrogen, but actually polyethylene can tolerate blends of up to 100% pure hydrogen. So parts of certain gas networks are already becoming tolerant to very high levels of hydrogen concentration. Others can take low blends of hydrogen as well. So that's something just to bear in mind. And then when we talk about some of these bigger blue hydrogen projects that are being considered, so some of you may be familiar with the projects around HyNet in Liverpool or Net Zero Humber, these types of projects. We're talking about injecting hydrogen in blends into the gas grid for the most part, some of which is going through existing boilers and burners on industrial sites that are being modified to take hydrogen. Others are going to be dedicated lines where they may be combusting up to 100% hydrogen. And again, there are sites that have been doing that for a long time. So if you go to the Innovin site in Runcorn, that site has been combusting 100% hydrogen as a byproduct of its chloralkali process for over 50 years. So again, a lot of this is probably familiar, but we can always cover this more from the questions. So just sort of to close up and repeat on some of the common themes, it's really important to emphasize here that the insurance of hydrogen is not new. What is new is the way that some of these hydrogen projects are being configured and the way that hydrogen as a product is being used. And that's the piece that I think is critical to focus on, and taking the lessons and the understanding from those sectors within the insurance market that have familiarity with hydrogen and bringing those learnings into the renewables market and being able to also draw on learnings from other early renewable systems, including biogas, is really important. It is the case that there will be some creative thinking needed around certain products like business interruption and around third-party liability. So hydrogen is not a pollutant, so you're not going to have soil contamination if there's a leak, and you're not going to have those legacy liability issues, but you do have other issues to consider, like the blast radius concerns and other safety concerns with regards to leaks. Obviously, the other component that people have picked up on is that for green hydrogen, much of the market might be distributed and so decentralized. That then may mean that unlike a large chemical site today or a large refining site today, you do not have the same number of people constantly on the site with that same level of technical expertise monitoring these assets. And so how do we ensure that that is still safely done, still done in a robust way without imposing huge costs on these distributed projects by having a very, very large permanent presence there? And I think to finish off, the industry on the green hydrogen side and indeed even on the blue side, when we talk about energy, is still nascent. There is a huge amount of potential. There are a huge amount of projects, and the opportunity for decarbonization is significant. But there does need to be lessons, and there does need to be support from others with experience in the sector. I think there's a lot the London market can offer to help when we're structuring projects and to help developers and to help other energy businesses to understand how hydrogen risk will be perceived and to get lenders comfortable with those components as well, so that we can unlock and access all the opportunities that hydrogen can bring to the market. And so with that, I'm conscious of time. I want to thank you very much for the opportunity to speak here today, and I'll obviously take questions later.
Chris, thank you for that very informative presentation. I think it demonstrates the complexity and the interconnectivity of the hydrogen space in the future. Certainly provides the insurance market an opportunity to look at how it can provide a holistic solutions across the complete value chain for hydrogen. I'm going to now pass over to Andrew, DNV. Andrew, if you'd like to take the presentation.
Yeah, good morning, and thank you very much for allowing us to present this webinar. I'm just going to share my screen at this moment in time. Okay, can everybody see that? Yep.
Yes, we can.
Okay, just to talk a little bit about the hydrogen and the energy transition, and something Andrew made a comment at the very beginning about the North Sea. I think the North Sea was a significant challenge in how it brought North Sea gas to the UK. We're probably now with a bigger challenge going forward on how that fits into the energy transition going forward. There was a significant amount of research undertaken during the North Sea and the conversion to natural gas in the UK from Towns gas, and a lot of research which is continuing for a long time. So this hydrogen aspects is going to continue and be one of the biggest challenges. So just like to go through some of the slides what I've prepared. Some might be repeated slightly from the previous slide. So DNV, Global Quality Assurance and Risk Management Company, our main purpose is to safeguard life, property and the environment. So very much focus on what we're doing today. We heavily get involved in the energy transition outlook. We've produced a number of reports from about 2017, just to go through a series of how the energy market is going to change. What are the emerging energies, hydrogen, renewable, existing fossil fuels, LNG and things like that. But more focusedly, closely working on hydrogen, what the topics are on hydrogen, has an energy carrier, and then decarbonising heat, which is one of the significant challenges going forward, and then hydrogen and electricity value chain. So these are available for downloads and get an understanding of where we are. So part of where energy transition timeline is understanding where we are at this moment in time. Collectively, we're taking this information from about 10 geographical jurisdictions, countries, all having different positions of where they are in the energy transition. Some more developed, more mature, some are still in the infancy stages. So we're looking at certain points, 2018, 90% of the energy mix was non-fossil fuel. Looking towards 2045, 46% should be an energy mix from there. Further detail, COVID drop off on significant energy demands, as we're all aware from that point of view of transportation, traveling and things like that. Energy, we're looking at a peak energy demand of 2034, and then natural gas peaks, but then obviously turns off into some areas from there. So hydrogen production, Chris has already mentioned this from this point of view, so don't want to dwell on that, but obviously at this moment in time, as things develop, it's a supply and demand journey from that point of view. As things develop, renewable energy will grow significantly, but obviously that's basing it on the demand from a consumer or an industrial point of view as well. Unique position for DNV. Obviously, we provide technical and business advisory services from the production, transportation, and also utilization points of hydrogen and cover the whole value chain. So really from a maritime aspect to a transportation on land to the types of burners and power aspects to be used. So cover the whole project life cycle at the moment. What I want to talk about today is a little bit about the R&D and innovation aspects as well. We've seen a little bit about the concept selection and operations, but talk a little bit about the R&D and innovation. And that's a legacy we've been involved in the past, from North Sea research into natural gas research and heavily into LNG, and now understanding the comparisons to hydrogen from a, shall we say, a safety point of view, a risk point of view, but also understanding how it's managed from that point. So regulatory issues at this moment in time. This is just a slide from the EU. So a lot of discussion on hydrogen guidelines, working with the gas transportation companies, the TSOs, the end users, fueling stations, but also the production aspect. So there's some challenges going forward on regulatory issues, bearing in mind a lot of these are already frameworks and foundations are in place for natural gas. They're not quite there at this moment in time for hydrogen. So it's understanding those aspects of repurposing gas pipelines, safety considerations, rules for hydrogen and ammonia fuel ships, classification and things like that, subsurface storage of hydrogen, road transport, and footprints and connecting electrolyzers and the electricity grid. So there's lots of things to go and focus on. So our research facilities are based up on flow testing, calibration services, materials qualification, pipelines, metallics, and then some full-scale testing aspects. So all built and form a part of a transportation and use of hydrogen aspects as well. So Spade Atom itself, where I'm involved, is has been well developed and well used as a research and development centre. As Andrew said, that there's probably a number of people on site who've already attended this. And if you do get the opportunity, it's well worth a visit. We've got high pressure storage on site. It's a very remote and secure site in the northwest of England. But we also have the ability to do large scale major hazard testing. And we've also got hydrogen storage, which has just been commissioned as well. So basically, our services approach to hydrogen research programs is understanding the transportation of hydrogen, looking at the hazards, the behavior, and offer some sort of risk management to understand how it could be operated, maintained safely, and also how it complies with any new safety regulation which is going to be in place. As Chris said, hydrogen has been used in the past. There has been some research done on hydrogen. We've completed some research on a hydrogen filling station for Osaka Gas, understanding the different types of accumulation of hydrogen from that point, understanding how it builds up, and also what happens if it does ignite or it does reach a certain point from there. So those types of research needs to be undertaken to understand consequences, understand some of the risks involved in there. Liquid hydrogen research, we're seeing more and more marine aspects from there on small scale at this moment in time, but that potentially will go large scale with potentially the transportation of liquid hydrogen, ammonia as well at some point. So it's understanding those aspects. And this particular project was what risks or what challenges on during bunkering when they were supplying and loading hydrogen from there. So this piece of work was done about 2 years ago, looking at how it might disperse, ignite, and build up in certain enclosures and things like that. So we have the ability to design bespoke rigs to understand the behavior of hydrogen or any other types of materials as well. Particular ones on confined spaces, how it builds up from that. We mentioned about existing transportation, and Chris mentions about polyethylene pipes for the gas distribution systems. So a lot of it is understanding about repurposing of assets, potentially whether it's blending, but also at some further down the line, it could be repurposing it with 100% hydrogen from that point. So this project H21 is ongoing with Northern Gas Networks. It's funded by the government through Ofgem. The houses you see at this moment in time on the video is DNV High Street. We built these houses to do hydrogen research. There's 3 houses, all of different types of flooring. One's got a loft, one's got a cellar. So it's understanding if hydrogen goes into that, how does it behave, similar to natural gas as well. So this project's ongoing, and it is advancing significantly from that. This just a little bit of understanding the hydrogen at Spade Atom. We're active research partner in a number of projects, H21. We've completed work packages for the government High for Heat project, which Chris mentioned, which is being funded by BASE, but led by Arab. It also looks at high pressure storage, low pressure cryogenic, and understanding the knowledge gaps on hydrogen from this point of view. And this is just a short video just on some of the research we do and demonstrations we do with hydrogen from that point. So it's understanding what happens in if something ignites the risks or consequences in behaving from that. So that's a hydrogen deflagration, hydrogen detonation, on how what happens from that point, you know. These are all on slow speed cameras, so you can actually see how it builds up from that point of view as well. And a lot of this work is done comparable to natural gas to understand the differences, how it behaves from that point. So just understanding from the safety point of view is, at the moment in time, there's guides on gas safety regulations. So everything's in place for the gas requirements and pipelines. That's not quite the case for hydrogen. So there's a lot of work to be done to understand the differences of hydrogen on the transportation aspects. And then simultaneously in line with that, the regulators will be looking at how hydrogen has an impact on existing regulations or develop new regulations to allow that from there. So hydrogen work for H21, looking at the QRA, looking at test result validation of models, but also preparing draft safety management frameworks to allow the gas transporters to manage the hydrogen safely through projects or longer term. And it blended, maybe 20% blends or 100% blend from there. So this is the high street I've recently talked about. So this is involved in the H21 project and the High for Heat project. So this was purposely built. You can see a hydrogen ring main around this system, which allows hydrogen to be tracked into the house and understand how that behaves from accumulation, dispersion, tracking aspects as well. So very similar to all the work which has been done for natural gas over the years to be able to understand that. So, so these are the houses, and this is how the scenarios were set up to loads of service pipes feeding into the house to understand the types of leaks what could be identified, how it accumulates, but also how it tracks as well. Is it different to natural gas? Is it more buoyant? Does it disperse quickly and things like that? So that was all part of this process as well. At this moment in time, we've got 2 hydrogen boilers installed in there, so they're actually running on hydrogen, 100% hydrogen at this moment in time. The High for Heat project was looking at the build-up of hydrogen in particular areas of the house, in the kitchen and the living room. These are all sensors, so the whole building's very much sensored, built into the cavity walls, the ceilings, the windows, certain points, kitchen cupboards. So it's understanding how it builds up in its certain levels, comparisons of the methane and nitrogen releases. So that data was then fed into the High for Heat program to understand what sort of risk for comparable to natural gas, but also any ignition potentials. As you can see, room level leakage properties. You can see a remote control window, so everything was controlled at about a kilometer away from the houses. The hydrogen could be released or vented through the windows, automatically released and opened from that point. So everything was undertaken safely, controlled from that point. These were part of the H21, is looking at how things behave on a gas distribution aspect as well. So these are the polyethylene pipes, but understanding how things release differently from there, understanding what was done for natural gas and also replicated for hydrogen, so they get some comparisons from that point. So these were a small release size hole there to see what would happen if it was released from that point. Data gathering is very important. Obviously, instrument dispersion, thermal radiation, and overpressurization was captured from there. Ignition potential, ignition understanding. A lot of the work previously was done on natural gas to look at what things were could cause ignition. These were then repeated against hydrogen, for example, iPhones, car starter motors, all the way down to domestic appliances like a vacuum cleaner and things like that as well, washing machine motors as well. So that's data would then provide the differences for hydrogen compared to natural gas. So these were 4 examples of work packages from that point. Small releases were had allotments set up to understand how it might track in a garden with a flag surfaces or grass or a sand surface, so to build up from that point. This was the large releases to see what would happen if there was a release and it ignited, what type of data would be captured from there. As you can see, this is a hydrogen flame. This is odorless at this moment in time, but they are looking to put an odor in which would be comparable to natural gas, the same one. And this is explosion severity, understanding what might happen with a kiosk if it did reach the ignition point from that point. So all these were part of the H21 program, which is ongoing, progressing in detail from there. So the next part which we're undertaking is building up a demonstration grid, which is all polyethylene pipe, so looking at different scenarios on how they're going to manage it and understand how to manage procedures aspects, the activities from there. We've got a high pressure reservoir or pipe array which is going to store the hydrogen. Got a tank offloading facility and a control room here. So this will break down and understand the amount of procedures the gas companies have on different types of operational activities like flow stopping. These are all going to be repeated for hydrogen and see what differences need to be considered, what needs to be updated on procedures, safety aspects and things like that as well. So this demonstration grid is now complete. I'll just move on to that one. So we've got all this, that's the reservoir storage supplied by National Grid for the H21. So this is the construction aspect. So everything which was comparable for natural gas is being supplied and going to be reviewed for hydrogen aspects as well. So it's about repurposing, but it's also understanding the day-to-day operations from that point. So coming on to the main supply from there is then looking at the National Grid's program going forward. This is looking at the existing national transmission system, which currently supplies natural gas from St Fergus, Isle of Grain, Milford Haven, and supplies all the rest of the UK right into the distribution network. So that challenge is, can there be repurposed for hydrogen, whether that's a blend or 100% hydrogen. So this is the INTS Future Grid project, which is again a government funded project which we're involved with to understand how we can build repurposed assets and do under testing from there. So building a test facility, what we're doing is looking at how repurposed assets from National Grid's transmission system can be decommissioned, transported back up to Spade Adam, and then reinstalled into this system here, which will include block valves, pipelines, entry points and exit points. It gives the whole complexity of a beach to meet a test facility or research facility to look at how things need to be done for hydrogen. Bearing in mind, procedures need to be understood and developed on hydrogen. Engineers need to be trained at this moment in time. There's very much a small demand or small knowledge capability on hydrogen that needs to grow very quickly. So people have the knowledge capability to understand and manage hydrogen going forward. So these are the entry points which are taken from location, Teesside, Bacton, various points of block valves, decommissioned, repurposed up at Spade Adam, pipelines, exit points. So everything coming from a regulator, a flow meter, filter. How does it operate on hydrogen? Can it be used on hydrogen? No leakage and things like that from a safety point. Understanding, bearing in mind, a lot of these assets have been in the ground 40 years. So what condition are they in? What can be done from that point? So this would be a typical part of this facility would be taken out, decommissioned and transported up to Spade Adam and put back in the facility as part of the program. So this is the design of the facility, which will link into the H21, decommissioned assets, entry points included, control room and a hydrogen storage reservoir as well. So once this is up and running, there'll be a testing program which looks at operations on valves, compressor, metering assets, flow control and things like that. So everything what is currently done on the transmission system could be repeated here for hydrogen at different blends. So that's the facility at this moment in time. This is the DNV High Street. This is the control room. This is the H21 facility there with all the distribution pipework below ground. This is the high pressure storage control room, and this around here will be the facility for future grid as it's starting to be developed with the project now. So as you can see, it'll be the world's first, shall we say, beach to end user facility where things can be tested on research, operational aspects, but longer term, when you think about it for the hydrogen journey, the amount of knowledge transfer and development of staff will need to be undertaken as well. Development of standards and things like that as well. So that's the end of my presentation, just on the journey we're undertaking now at this moment in time on hydrogen and some hydrogen projects as well. And I think it's fair to say that it's not just the UK who are getting involved in the research on hydrogen pipelines or repurposed pipelines, but we're seeing a lot of European, the US are looking at blended projects, potentially down to trials on unoccupied sites as well. And also from a Middle East and Australia point of view, they're looking at how they can manufacture hydrogen, but also transport it very similar to what they do now with LNG from that point. Okay, so just like to thank you for the time. And again, any questions, I'm happy to answer at the end.
Okay. Thanks, Andy. That's very informative and goes to show the amount of research that's necessary for this transition in terms of the conversion of what we have as an infrastructure now, but also for the future sort of scale up, both at consumer level and industrial level. So very informative to see the research that's going into that. We do have some questions that have been sent to us prior to this webinar, and a couple more come in, which I'm going to integrate. If I may, Andy, first of all, there's a question regarding are the facilities at Spade Adam compliant with ATX regulations? And at the moment, do you see that the codes are sufficient, or there's going to have to be a rewrite of codes for hydrogen?
I think at this moment in time, there is compliance with the existing standards from that point. But in the UK, for example, there's no specific standards on hydrogen transportation for pipelines and things like that, other than an American ASME code. The Institute of Gas Engineers are developing standards at this moment in time. So there is going to be a lot of development on standards. The American code is primarily about new pipelines, and there needs to be some work undertaken later on to look at repurposed pipelines on fatigue, fracture toughness, and things like that as well, and how it impacts on potential hydrogen embrittlement from there. Also further down the line, when you look at boiler manufacturers, installers, everything is focused on natural gas at the moment in time. There will be developments for standards on hydrogen from that point of view. So there's a massive journey to undertake on standards, suitability, but also understanding the risks involved from that point.
Good. A question for you, Chris, and again integrated from a question sent to us earlier, but also one that's come in. The question that's come in is, what are your major challenges in terms of commercial viability? But linking it with a previous question, do you think governments can afford to subsidise hydrogen given the levels of debt created by the pandemic? You might be on mute.
Yep, great. Sorry. So yeah, I guess there's two parts. So clearly, government does have a significant role to play on the setting of regulations and standards. And I'm not going to be able to speak as knowledgeably to that as as others already probably can and have done. But I think if you want to look at things like the high for heat or funding for H21, or indeed a lot of the other funding and standards work, there is a huge amount being done. It is also international. I mean, ASME was referenced, but the EU is also doing quite a lot, and there is quite a broad discussion now happening in various different governments around things like a low carbon hydrogen standard, and trying to make that internationalized as well, to say what constitutes low carbon, what are the thresholds for that, and trying to align some of the early principles in Europe that are branded as Certify, which is a process they started on hydrogen, and taking that across into different end sectors. So there is definitely work, more work that could be done, and there is already quite a bit of work that is being done. But I think government seems to be broadly in line with that, and certainly engagement we've had with people like DEFRA and HSE on that has been quite positive to date, although probably more needs to be done with groups like Ofgem to understand the grid implications of it. Does government have the money? I guess is the crucial second part of the question, to be supporting this transition. It's a very good question. I mean, I think there is probably the most unpleasant conversation that is a broader energy sector transition conversation, is that if we are serious about net zero, then regardless of technology, the message at some point to end users, investors, and government is we need to consume less energy, change how we consume energy, and pay more for energy. Unfortunately, those are the only three ways you really get to net zero globally in the time frame that we have. And all three of those are politically toxic messages. So how that is managed is going to be a complex negotiation. Now, I think where there is a more positive story for a number of countries is around this kind of industrial base and sort of rebuilding jobs within a lot of countries where we've seen jobs leave. And, the UK has fantastic heritage in this space. So I know that that's, at least from the UK government side, the fuel cell is discovered by William Grove, a Welshman. Cavendish is the original discoverer of hydrogen in the UK. So there is a sense that this, if done right, could lead to a lot of jobs, and that is what is triggering a lot of the interest in Europe, North America, and in the UK to get involved. There are still questions about whether this might be a repeat of a China type story, which we saw with the solar PV side. And I think if that was the case, and we did see that those jobs were not materializing, there would be more questions around longer term support. But certainly for the next 5 years, all the feedback we are getting from both the UK and from international is that countries see this as a race that they are willing to put resources behind for now, the next 5 years, to try and be the leader in. And then I think there will be a question kind of in 5 years' time of how has that investment gone down, and then do countries want to continue to invest at that level or not? But certainly for the next 5 years, there's huge amounts of support, and I suspect you'll see a lot of announcements at COP26 to that effect as well.
Right, definitely a space to watch that COP26. A question to both of you, and in a way it's partly answered by your previous question, Chris, but the use of hydrogen, as the use of hydrogen accelerates, would there be a concern about the dearth of qualified personnel? Obviously it's job creation, but maybe Andrew first, are the engineers there? Do we have sufficient engineering expertise available to deploy and train?
Yeah, I would suggest so. I think obviously from this point, there's when you look at a downstream from a central heat installer, got the right person with the right skills, the right knowledge to be able to upskill them to hydrogen. And the thing would be a gas central heating boiler would be replaced with a hydrogen boiler, so that would be processes in place to just upskill those people from that point. The existing engineers' skills within the gas companies and transportation companies would quite easily be upskilled or knowledge transferred onto hydrogen from that point. They already have got the safety requirements, the understanding of the processes and things like that, you know. So that would be programs which could be developed, but again, it would be a big upskilling from that point. And again, I think you're starting to see some of the North Sea operators where the skills are then coming onto renewables. There's still the opportunity for some of those skills and workforce to be upskilled to hydrogen as well. So certainly a good opportunity for young people to get involved in hydrogen as well, because it's going to be a long-term future in the energy market aspects. Okay.
And probably just following that, I'd say that, that we do have in some markets, and again, we talk about the UK a lot, but I mean, I guess this is meant to be more broad, but if we do talk about the UK, I mean, groups like OG UK and others are very, very clear that they see hydrogen as a very good opportunity for skills transition, and for using a lot of that expertise. It's certainly the case that a lot of the large EPC companies in the UK are very much gearing up towards this sector, which they broadly brand energy transition, but whether it's KBR, Worley, Petrofac, or others, most of those companies are taking a pretty active and aggressive stance to try and get into this space more. There's certainly not a challenge when we talk to universities about young graduates that are very keen to get involved in this space as well. There are a lot of young graduates that want to get involved. I think what we're going to see, though, is certain sectors of the hydrogen market where there's a lot of people that might be qualified or who have skill sets that could be adapted, and others where there are greater gaps. So for example, on the electrolysis side, I do think that is a slightly weaker area for most, because it is just a relatively limited market. People forget, but the ITM Power, which is the largest UK electrolyzer manufacturer and the first PEM gigafactory in the world, the entire company is 200 people. If you were to take all, alkaline and PEM electrolyzer manufacturing staff in the UK, you'd probably be under 1,000. So there is not a lot in that specific space. But if you want to look at people working on hydrogen combustion, that number's in the thousands, if not 10,000s. Most boiler burner manufacturers in the UK have a hydrogen ready or hydrogen prototype system ready to go, and engineers who understand what it looks like, and some that have even run tests. Dunphy have done tests up at HyNet with Unilever and with others, but there's no shortage of others there. So I think it's specific components of the hydrogen value chain you will see pinch points, but probably not actually across the broader market. There are the skill sets.
Okay, cool. Conscious that we booked everybody's time for 1.5 hours, and there's no intention to use all that. So one more question, and then maybe we can just round up the question. What is China's strategy towards hydrogen, and will their adoption of hydrogen power be needed to help drive down prices like it did with solar power? So are we dependent economically on the outcomes of China?
So maybe look at it slightly differently. So with solar, if you want, solar was a kind of two-partner dance, right? You needed this price support, and you needed the incentives from Germany and to some extent from the US to create that demand. And then China was able to come in and capitalize on that demand. That also was a quite unique geopolitical point in China's history because the cost base of manufacturing in China was still quite low. The average wages in China now compared to that solar boom are dramatically higher. So that manufacturing competitive advantage that China enjoyed then is not as strong as it was now. And I think there's definitely a sentiment that in European and North American markets, they cannot allow the same story to happen again. So I think that piece of the story is not the same as the solar story. I think the bit that is the same is that there will be a huge amount of scaling and that there will be cost support probably put in to do that. But I think it is going to be probably a little bit more nationalistic, which may delay some of the cost declines than we saw previously, because people will want to keep more of those jobs. But that also may mean that there's more of a public support for price support, so that can survive a little bit longer than we saw with solar, where we had this huge boom in the solar industry, and then we had a complete transformation of the price support mechanisms around that, and actually a lot of market confidence lost when the subsidy regimes that were put in place in Europe changed in some cases overnight and quite dramatically, and actually did a lot of damage to the sector. I think that's how I would tend to see it. China does have a very strong approach towards hydrogen, and it's mostly driven by air quality. And I think this is something that maybe is a good thing to end, if you like, my bit on this. When we talk about hydrogen, too often when we talk about the wrong things, the reason why people transition to different energy fuels or energy sources is very rarely to do with efficiency, cost, or safety. If you look at electricity, the reason why people moved from gas lighting to electric lighting in New York and other places was because it was a better product, right? It was consistent light, better quality light, and there was an affluence element associated with it. If you look at why people switched from horses to cars, it's again, it wasn't reliability or cheapness, it was a better product. So when we talk about hydrogen, people don't make that case enough, but they should. 100% hydrogen domestic heating system has no carbon monoxide poisoning. That's actually quite a significant health and safety implication compared to what some people are familiar with. Or the other one we talk about is with cars. Cars which are hydrogen based rather than battery electric are mobile air purifiers, because for a fuel cell to work and to create electrical current from hydrogen, it has to filter oxygen from outside the vehicle. So it has filters on the front of the car that take PM 2.5 and other particulates out. And if you want to see this, there's a very good YouTube video Hyundai have done with a vehicle in London with dirty air at the front and a big bag and a clean air bag at the back, and they show the car filtering it. So for China, when they're talking about air quality, and India, hydrogen is going to be a big part of the story, but probably less to do with the energy transition piece and more to do with the air quality story, because these are hugely polluting cities. It's hugely impacting efficiency, and it's a public health issue. And so that probably will be what drives the uptake of hydrogen there on the vehicle side for air quality, rather than on the kind of large scale gas deployment initially there, although there will probably be some of that too.
And that's certainly a nice point to finish on in terms of its music to the ears of ESG representatives within insurers, seeing that we're moving into an environmentally friendly output. I'm going to summarise and wind up the webinar. Firstly, thank you for nearly the 200 people as guests who have made their time available to join us today. Hopefully you found both presentations useful in terms of identifying the number of activities, industries, organisations being coming together to look at the hydrogen space and the scale up that's going to occur and rapidly. And equally, the amount of research and technology being deployed to understand the risks so that codes can be drawn up and that can be translated into hopefully productive underwriting. But certainly from the Price Forbes perspective, we see it as an interconnected business. It has a supply chain from initial manufacturer, transportation, the use in transportation, construction, integrated industrial and domestic and commercial usages, and then conversion to power and the integration of renewable sources as a fuel in itself to the hydrogen transition. So Price Forbes is looking to develop a holistic hydrogen team, and we look forward to engaging with the insurance market as the hydrogen usage and developments expand. Thank you, Andrew from Spade Adam, for joining us. Look forward to seeing you up there again and witnessing some of those pretty large explosions. And Chris, thank you again for joining us and sharing your insights to the developments and the commercial aspects that face the development of hydrogen in the UK and world. Paul, if you have any final comments that you would like to say from Price Forbes, otherwise, thank you again, everybody. Okay, thank you.
Thank you.
Speak soon. Bye-bye.
Thank you. Thanks.